right, my darlings, we are looking at secant and cosecant graphs, page 1. There will be a page 2. But if you get down sine and cosine graphs, then graphing the secant and cosecant graphs are super easy. It just takes one additional step. Well, I guess 2 additional steps. So for cosecant, we start with its reciprocal sine. So you can see here, there's the sine curve, the basic sine curve, no transformations, no change of period, no change of amplitude, just the basic sine curve. But remember, cosecant is the reciprocal. Well, the reciprocal of 0 is undefined. So anywhere that the sine curve hits the midline, you're going to get the reciprocal of 0, which is undefined. So you get all these asymptotes. So everywhere the sine graph hits the midline, you have an asymptote. And then the cosecant graph starts at the maximum of the sine graph and approaches the asymptotes. Or starts at the minimum of the sine graph and approaches the asymptotes. So you keep getting these curves. So the cosecant graph is actually split into multiple different curves and approaches the asymptotes but does not actually hit them. So it's actually in pieces. And we can write a single equation to represent this infinite number of asymptotes. So basically you just pick one to start with, and then the distance from this asymptote to this asymptote is pi. So I wrote asymptotes are x equals 0 plus pi n, because this would be plus 1 pi, plus 2 pi, or plus negative 1 pi, plus negative 2 pi. But 0 plus pi n is just pi n. So the asymptotes are the vertical lines, x equals pi n, where n is an integer. 1, 2, 3, 0, negative 1, negative 2, negative 3. All right, so for secant, we start off by graphing cosine. So here's our basic cosine function. Again, though, the reciprocal of 0 is undefined. So anywhere cosine hits the midline, we get an asymptote. From the maximum points, you draw curves going up, approaching the asymptotes. From the minimum points, you draw curves going down, approaching the asymptotes. And again, we can write one single equation to represent this infinite number of asymptotes. So we just pick a starting asymptote. So here's an asymptote at pi over 2. And the distance between the asymptotes is pi n. Is pi, but we want to add pi n. So pi over 2 plus pi n. Again, n is an integer. So this would be pi over 2 plus 1 pi. Or pi over 2 minus 1 pi, minus 2 pi, minus 3 pi, and that will end up giving us all of the asymptotes. Here's something to notice though, this thing that we add on the end, it's half the period. The period is 2 pi, we added pi in. The period is 2 pi, we added pi in, because there's an asymptote in the middle of the period. So say the period was 4 pi, then this would say 2 pi. Say the period was pi, then this would say pi over 2. So it's just half of the period. And that finishes page 1.